Hi and welcome to Cherry Pie Math. This video is going to introduce scientific notation, which you will see often with science, believe it or not. To get things started, and I've kind of talked about this in other videos, I want you to take a look at these three exponential expressions and try to figure out what the exponent would be for each of them. So pause the video, take a look, and see if you can A, figure it out, and B, find any patterns. So you might know already, but tens have a pretty cool property that the exponent is equal to the amount of zeros. So the first one, where we have 10,000, there are 4 zeros. So the exponent would be 4. In the second one, where we have 100 million, there are 8 zeros. So the exponent would be 8. Another way to visualize this is to start from the end and draw the amount of spaces of zeros that there are. The last one is a decimal, but the same principle applies. 0.1 is actually 1/10, which is 10 to the negative 1. And we'll get more into decimals later. This one was kind of tricky because we can't really just count the zeros quite as well. Anyway, so the exponents of 10 and the simplified value have a lot to do with each other. The exponent represents the amount of places from the decimal. So scientific notation uses this property and introduces numbers other than just 1 and 0. So we're going to be using the property that we can count the number of places from where the decimal would be. Kind of like how in the bell work we were talking about how the number of zeros tells you what the exponent will be. We're going to use that property of the tens to do scientific notation. So let's remember really big numbers and what they're called. We have 10, 100, 1,000, 10,000, 100,000, 1,000,000, 1,000,000,000, and 1,000,000,000,000. When we get to really big numbers, if we have anything else other than 1 and 0, trying to read it out loud is such a headache. Like if I wrote like 467,938,327, nobody has time to actually read that out loud. So there has to be a better system to represent these numbers, because when we have too many numbers, like I said, it's annoying to read it out loud, first of all, but also like nobody really wants to see that on a piece of paper. So kind of going along with that, imagine you have someone who makes 10,001 a year and a person that makes 10,000 or 100,010 a year. So is there really a significant difference between them? Not really. Like that's enough for maybe a Happy Meal. So if they told someone their salary, they probably wouldn't even say the 1 or the 10 at the end. They would just say 100,000, because that's the important part. The part at the head of the big number is the part that matters. That's the part people care about. So we have scientific notation. Scientific notation is a way to show big or small numbers using powers of 10. We can convert to scientific notation or convert back depending on our needs. So let's show how to do that. If you want to convert a number to scientific notation, you write down the digits, and put a decimal after the first digit. So in the first one, I'd write 587 and put a decimal after the 5. In the other one, I'd write 456 and put a decimal after the 4. Step 2, count the number of spaces from the original decimal to where it is now. So if I start with a decimal, I'd count from the decimal to where it is, which in this case is 5 places. If I start with a bigger number, I'd go from the end, since there's an invisible decimal there, and I'd count the number of spaces leftwise, which is 7 spaces. Step 3. Write step 1 times step 2. Step 2 meaning like with 10 to that power. So the first would be 5.87 times 10 to the negative 5th, since it's a decimal. The second one would be 4.56 times 10 to the 7th. And the reason we have 10 as that base is, like we said in the bell work, like we've been saying this whole video, is 10s have that property that shows us like how many spaces from the decimal it is. So every time I have that exponent, it's showing me how many times I've kind of shifted from the original decimal place. So we're basically using the tens property of exponents here to cut down the amount of writing we do, since it's just telling us how many places to move the exponent. Converting back to a number is pretty similar. So first, you're going to write down the digits without the decimal point. So 587 and 456. Then you move the decimal place the exponent amount of spaces. So in the first one where the exponent was -5, we know it's going to be a decimal since it's a negative number. And I would say right or left, but honestly, I get super confused when I have right or left, and because like when you're converting one way, it's one direction, and when you're converting the other way, it's the other direction. To me, it's easier to remember if it's a negative exponent, it's going to be a decimal, and if it's not if it's a positive exponent, then it's going to be a big number. Anyway, so it's a decimal, and because it's a negative exponent, so I'm going to move it to the left, and I'll move it 5 spaces. And in the other one, it's a positive exponent, so I'll move it to the right to make a big number, so it would be 7 spaces to the right. Then step 3 is to fill in the extra spaces with zeros. And we end up where we were before. We'd have 0.0000587 and 45,600,000. So just a reminder, if it is a decimal, your exponent should be negative. If it's a large number, your exponent should be positive. So other things to remember, there should only be 1 digit in front of the decimal when you're doing scientific notation correctly. The exponent of the 10 will tell you how many places to move the decimal point. And remember that big numbers make a positive exponent and decimals are a negative exponent. And finally, remember to fill in the blank spaces with zeros. Don't just leave them empty, because then they'll be sad numbers. Anyway, I hope that helps, and good luck.